Thanks, everybody. First of all, welcome. You're very welcome here for my talk here today. I'm going to try to give you an overview of some of the work I've been doing and my colleagues have been doing in the Tyndall National Institute, which is in Cork. It's an institute which is part of UCC. And we do a lot of different areas of scientific research and device development, but one of the strongest areas over the last few years has been in the development of technologies for space. So when I was approached to do this talk, I thought I would try and give you an overview of what we do, and as well maybe give you an insight into the type of basic challenges that are out there when you want to get something up into space, and hopefully as well make you realize that space technology isn't as far out as we all think. It's something that we can get involved in, and it's something that Irish companies and research institutes have got involved in the past. And if any of you have an interest in either science or electronics or astrophysics or the whole space area in general, I'd advise you to just think twice about it, and hopefully today you'll see that it's an area that there's a lot of potential out there if you want to pursue a career in it. Okay, so the talk overview is going to look something like this. I'm going to start off with a few what I call space technology myths. They are preconceptions or misconceptions that I think the general public have, and probably what I had myself before I started into this area a few years ago. I'll move on then to what are the critical space technology challenges. What are the real problems you have to overcome to get up into space and to keep something going up in space. I'll move on to developing and testing space technology in Ireland. I'm sure there's a lot of areas here you're not familiar with, so hopefully you'll be surprised and encouraged by what's going on in Ireland in the whole space technology sector. We'll move on then to technologies that they were initially developed for space, but they've actually come back down to Earth. So they're everyday technologies that are being put to very good use. And finally, we'll look at what I call life in space or career options. If somebody wants to go down this line, there are more options than you might think. Okay, to start off with, I found this picture a few days ago, and it really amazed me. Anybody want to take a guess what it represents? It's what's called space junk. There's 12,000 pieces of junk or technology, whichever way you want to look at it, going around the Earth at the moment, at different distances from the Earth. Satellites, pieces of rockets that fell off. Lots of them do very useful things, but some of them don't do anything. So we've got 12,000 pieces of junk floating around the Earth at the moment. Most of them will stay floating. Some of them might get caught in free fall and end up back down on Earth. So what I hope would just represent here is there's a lot going on in the whole space technology sector. Even though only 30, 40 years ago was the first time we actually put something up into space, there's a lot going on since. The second one, this is the only piece of business I'm going to show here today, the only facts and figures. It's a pie chart representing the amount of money that's being spent in the space industry at the moment. That's the total, 257 billion. It's a massive amount of money. It's mostly been spent for one country by the American government. The international governments is much small in comparison, but you look here, 2/3 of the total budget is being spent by the commercial sector. And what that means is companies putting satellites up into space for everything from satellite TV to mobile phones, etc. So what I just wanted to get across is this is really big. There's an awful lot of money being spent in space today. NAM is only 70 billion. They're spending 250 billion a year on space. So when you take that into mind, space is big business. Let's look at a few technology myths, as I call them, that are out there at the moment. First one, space technology is futuristic nonsense. In other words, when you think of space technology, what comes to mind first? Star Trek, probably. Deep Space Nine, whatever you want, spaceships going into outside the solar system. I'm going to try and show you that no, people have been thinking about space for a very long time. Secondly, space technology is not for the ordinary Joe. In other words, when we think of space technology, we think of, again, the kind of whole Star Trek idea, and that, okay, all this technology is no use to you and me. But in fact, it is. Number 3, space technology is just a few crazy scientists locked away in a few labs, in NASA or the European Space Agency or whatever, developing crazy little technologies that are no use to anybody. And again, I think we'll show that that's not the case, at least most of the time. And finally, Ireland and space. At least up to recently, most people would have laughed at the idea of Ireland doing anything for space. But hopefully you'll be surprised and encouraged when you see that there's a lot going on in Ireland as regards space technology development. So the first one, space technology is a load of futuristic nonsense. And as I said, this is what we think of when space technology comes into our minds. Star Trek, guys in dodgy clothes, firing lasers, teletransporting, whatever. But when I started to think about this, I said, okay, who was the first person to actually use a piece of technology and interact with space to help improve their lifestyle or whatever? And Google, my good friend, came up with this. 32,000 BC, the first star chart found in Germany, in a cave in Germany. And similarly, in France, somebody was already drawing up stars and looking at the night sky. And obviously, maybe he was totally bemused by it, but he was starting to think, okay, maybe there's something we can use out of this. So, a bit dubious as to whether that's space technology, but definitely as we move on, and this is something we should all know about, Newgrange and the megalithic chambers that are in Meath, mostly in Meath, but somewhere around the country. But the most impressive of them are places like Newgrange and Knowth and Douth. And what they had been doing is they had been using the sun to tell them what time of year it was. And Newgrange, even up to this day, will tell you what is the shortest day of the year within a day or two. And that was extremely useful back then. I mean, they could plan their whole year around it. Their lifestyle was based around agriculture, so once they know what the shortest day of the year was, they could start planting their crops or whatever and start planning for the year. So even back then, people were thinking, okay, I'm going to use space for something that's going to help my lifestyle. As we move on in time, people started to use the sun and the stars to navigate, to get places. There's evidence that maybe St. Brendan travelled to America, to the New World, by looking at the sun and the stars. Definitely by the medieval times and the mid, the 1100s, the turn of the century, of the first century, of the first millennia, people were using devices to look at the sun, look at the stars, and tell them where in the world they were, and they could navigate to new countries. More recently, in the 1700s, people were starting to develop telescopes. They were actually looking at extraterrestrial bodies. Okay, the big jump happened when, after the Second World War, really, people started launching rockets up into space. And now we've gone outside our own solar system. The Hubble telescope is looking at galaxies outside the solar system, and we've all gone all the way into the sun. We've had orbiters going around the sun. And man, of course, has gone to the moon in 1969. And we've got a space station up there. So, okay, the bottom line is we've gone all the way from just looking at the star and the suns, the sun and the stars, to where we've got to a stage where we can travel to another planet, the moon, or a satellite planet. And in 2016, the European Space Agency is actually going to send a satellite to orbit the sun. It will be one of the most advanced pieces of technology ever developed. So we've really come a long way, and I've put down, if anybody's interested to take a brief look at how the whole concept of space evolved, I would recommend taking a look at this book, The Sleepwalkers, by Arthur Koestler. Okay, space myth number 2. Space technology is not for the ordinary man or woman in the street. When we think of space technology, again, we're thinking Star Trek. It's of no use to us. We're thinking space shuttles. But okay, when you think about it, could we live without satellite TV? Who here can get by without Sky Sports or Eurosport or whatever? Okay, we've got lots of stuff coming in cable now, but I'm sure everybody has their satellite up, their satellite dish up. GPS or sat-nav. Every taxi you get into now, they type in where you want to go. They have a picture up there. And I mean, you can see here, this is a sat-nav image of the science gallery. You can see down to, you can see people walking along the streets. It's frightening in some ways. Satellite weather images. Do we want to go back to that? Definitely not. Again, we have these fantastic images of the weather that can tell us, what's coming in the next 2 days, even in Ireland. And that's all down to having satellites up there and looking at the weather systems. Sat phones, it's not such a big issue in Ireland, but if you're stuck out in the desert somewhere and your mode of transport breaks down, your Jeep breaks down, having a sat phone could be the difference between life and death. And that's because there's a satellite up there that you can connect to and call someone for help. In the future, space tourism will probably be the next big thing. Instead of going to Australia or New Zealand, you guys will be saving up to go to the moon or taking a trip up into space. Projections are by 2030, there'll be 5 million passengers per year. So start saving. So the bottom line is, could we live without space technology? We probably could, but we've got so used to it by now, it would probably be quite hard. Okay, space myth number 3. Space technology. It's comprised of scientists locked away in their labs developing crazy gizmos that are no use to anybody. And things like Star Trek, again, don't help that when you think of the concepts that they're trying to come up with. But that's not true. When it comes down to it, space is comprised of 3 basic challenges. And they are power, control, and reliability. You need the power to get up into space. You need the control to be able to control whatever you've put up there. And you need reliability to make sure that once it's up there, it's going to keep working for a long time, because you can't take it to the garage or whatever. You're not going to fix it. Once it's up there, it's got to work for a very long time. It's cost enough to get up there, so it's got to work very well. So I'm going to start with number 1, the power challenge. And this was the challenge that limited how man could interact with space for so long. They basically couldn't get anything outside the Earth's orbit, and that's because of gravity. And you might be familiar with this equation, and if not, you probably will be in the next few years. It's Newton's law of gravitation. Basically what it says is, if you have 2 massive bodies, they'll attract each other, and the magnitude of the force of attraction is proportional to how much mass is there, how big they are, and it's inversely proportional to how far they're separated. So the Earth is a huge mass, so it attracts everything to it, and that's why we're all standing solid on the Earth. And to escape the Earth's gravitational field, you need an absolutely huge velocity. And this is known as the escape velocity, and that's a summary of how you work it out. But the actual magnitude of it, for a rocket to escape the Earth's gravity, it's 11.2 kilometers per second. And that is really a huge velocity when you think about it. Jumbo jets fly at less than 1 kilometer per second. So you've got to go 10 times faster. So you've got to accelerate, accelerate, accelerate until you get to that speed. And once you hit that 11.2, you're gone. You can get out of the Earth's orbit. To actually get out of there, of course, the big technology development was the rocket. And ironically, that came out of one of the world's greatest historical tragedies, World War II. The Nazi regime in Germany had just developed the rocket at the end of World War II, and it was put to good use by the Russians when they sent the first rocket up in 1946. That's a picture of the first picture taken from a rocket from space in 1946, and that's the V2 rocket. So that was a huge step. That meant we could escape the Earth. So now at least we're up there. Once you're up there, you've got to consider, okay, how are we going to power it? How are we going to keep things going? And again, that was an issue because you can't be bringing tanks of petrol up into space, or it's just too messy. It's weight. Every kilogram of weight in the space industry costs about $250,000 to get it off the ground. So you don't want fuels. You want something light that you can put out there. And it was solar cells that enable that. Silicon solar cells were discovered in the 1950s, and they were actually very inefficient. They only give you about 10% of the light that hits a silicon solar cell is converted to electrical energy. The rest is wasted as heat. So people thought, okay, what use are these things? But of course, in space, the sun is directly shining on you the whole time. There's no day or night. It's daytime the whole time. And you've got an endless supply of energy. So that enabled technology to work in space. Okay, so the second challenge was control. You remember I said there was 3 challenges: control, power, and reliability. So once you're up there, you've got to think, okay, how am I going to control this thing? I've got it outside the Earth's orbit. How am I going to tell the rocket to turn left, turn right, to look at the sun, to look at some star? And the reason, it's just so far away. I've just done a little calculation here. If you were traveling at 1,000 kilometers per hour, that's 10 times faster than the speed limit. It would take you 16 days to get to the moon, years to get to Mars. It's mind-boggling, really. But technology has got so far that they can do this, they can talk to them, and they still are. I have a picture here of This is Pioneer. This was a satellite that was put up in 1968, and it's still actually transmitting. So that shows you the level of technology advancement that's been achieved. And this has been enabled by wireless technology and wireless transmitters. So basically, it's been mobile phone technology. It started off as radar, radio wave communications. It's becoming more and more towards the millimeter and microwave technologies. And that's what we use now every day in our mobile phones. So again, now you can get something up there, you can control it. The next challenge is reliability. How are you going to be sure it's going to work? And there's a number of reliability challenges. First, you've got to get over the whole reliability issue of getting off the ground. It's a huge challenge. You've got to go at very high accelerations. There's actually a demonstration out here downstairs. There's an astronaut talking about what it's like to go up into space and the liftoff. And he says, you know, when you hit this 3G, 4G times gravity, your whole body is just being crushed. And he said, you know, you come to the top of the liftoff and you just want it to stop. And this is a picture of somebody going down a roller coaster, and you can see how their face is distorted. So you can imagine when you're going up at this kind of acceleration, it's shocking. And vibration as well. You know, things are just shaking around so much. You're driving so much power out of the rocket. You're burning hydrogen and oxygen. And that if there's any weak link, it could be the end of the whole mission. And in the case of, let's say, Challenger, I don't know if you guys are too young to remember, but Challenger in 1986, it was a very, very minute detail. There was a little seal, a rubber seal, that had a crack in it, and that ended in the hydrogen leaking out, exploded, rocket destroyed, and the crew killed. So you've just got to be extra diligent, really. More and more, the reliability challenge encompasses extreme environments, because now people want to go to different planets. They want to go to the moon, they want to go to Mars, they want to go to Venus, Mercury. And then you've got to think about, okay, these planets are completely different environment to Earth. They don't have oxygen. Some of them don't, most of them, yet they don't have oxygen, but they have some really nasty atmospheres like ammonia. Methane is highly explosive, and hydrosulfide, really awful stuff. It would rust away most electronics and materials that we commonly use. And the temperatures are very extreme as well. If you want to go way out to the edge of the solar system, it gets really cold, down to minus 300 Celsius, something like that. And if you want to go in towards the sun, it's going up to plus 300, 400 Celsius. You know, it's getting really hot. So you've got to think about, okay, can my electronics stand up to those kind of extreme temperatures? And I think in general, the rule of thumb is in space, in full direct sunlight, if you've just got a satellite near the Earth, it gets up to about 150 degrees Celsius. If it gets shadowed, let's say you go behind the Earth and you've got no sun, it drops down to minus 60. So that's a huge swing in temperatures. Another challenge is radiation. You're up in space. You don't have an ozone layer to protect you. So you're getting all this UV radiation. You're getting charged particles as well. You're getting protons, electrons being coughed out by the sun, and they're hitting your electronics or your solar panel, whatever's on the satellite. You've got magnetic fields, which can mess up with your electronics, and you've got cosmic radiation as well, which have been proven to really mess up your electronics. So, okay, then the next thing you've got to consider, how do you tackle the whole idea of, or the whole area of reliability? That's good stuff, guys. And the way you do it is, okay, there are 3 rules of thumb. Contrary to what a lot of people think of, play it safe. Don't do something risky. A lot of people think space technology, oh, it's completely wacky stuff. They're going to take the latest technology and send it up into space. Incorrect. Generally, what the space industry does, it takes existing technology that has proven reliability, and they test it even more. They don't like taking risks. So they do every kind of a test imaginable. You think about what's it going to be like taking off, what's it going to be like up there, and you do those tests. You try to simulate the environment. And as well, if you can't simulate the environment, try and get some guy on a computer to simulate it, do computer analysis of it. And an example would be the space shuttle from NASA. It's been in use for 20 years, and it's going to be in use for another while because they haven't come up with anything better. So the kind of tests that they do, and I've been over here in the European Space Agency test center in the Netherlands, and it's really impressive what they've got over there. They try to simulate every kind of environment, from liftoff to space.